Hello, folks. This is video number 35 for the playlist of 3D Experience CATIA Generative Shape Design application. In videos 33 and 34, I went through the sweep icon uh, using the circle profile type. And we looked at all the 7 cases that can arise. So right now I'm going to be doing some wacky surfaces, which is using some of those cases that we discussed earlier. I refer to them as wacky swept surfaces because at least 3 of them are relatively complicated when you look at it the first time. But how it's generated is fairly straightforward using the swept icon, the circle option. So if you're in the generative shape design, this surface tab will give you the sweep option here, sweep icon. And it's one of the advanced icons because there's so many different things you can do with it. When you click on the circle icon, or with that option, you select this. This dialog box opens up, and notice that there are 7 cases, 1, 2, 3, 4, 5, 6, 7. And we have done pretty much, we have done all of them. In video 33, I did the first 3, and in video 34, I did the bottom 4 cases. And the examples that I'm going to do today are taken verbatim from this YouTuber, but it's the CATIA V5 version of it. So I'm going to basically replicate his steps and his dimensions and his approach using the 3D Experience CATIA. Okay. Okay, let's go with our first example. And let me draw 2 circles, semicircles, on this vertical plane, but of course I will do in different sketches. So select that, select the vertical plane, ZX, and on it you sketch. I'll draw a half a circle, semicircle, with the dimension that the fellow has. Excuse me. Okay, let's wait. So semicircle, arc, center at the origin, and the radius of this is 200 millimeters. Okay, good. And exit. Now I do another sketch. This was sketch 1. I'll do another sketch on the same plane, an arc. The only thing is that the radius will be different, and the radius will be 150 millimeters. Good. Exit. So this is the situation. We have 2 circles, and what we're going to do is select the surface tab, sweep option, sweep icon, and it's a circle that we're going to be discussing here. Profile typing is circle and 2 angles. So the option that I want is center and 2 angles, which is right here, center and 2 angles, right there. See that? Right there. So I select this. For the center curve, I use this thing that has a smaller radius, right there. Center curve is that inner one. For the reference curve, I use the outer one. Okay. Now, notice that what it says here is angle 0, angle 1 is 0, angle 2 is 45. Now, I don't want to use this. I will come back and do the laws as the fellow YouTuber in the indicated reference does. But let's see what we get here. Preview, we get something like that. But this is not what we want, or this is not what he does. Okay. So what he does instead, it goes through a law. Okay. And for the law, the first one, he uses angle 0, starting angle 0. First of all, use a linear, not constant, linear. For the start angle 0, and for the end angle 3600. That means 10 loops. 3600 divided by 360 will give you 10 complete loops. So whatever that thing means, let's not worry about right now. And then we say close. And for the second one, angle 2, again, I go to law. For the start angle, I use 100 degrees. I use a linear, of course, linear. And for the end angle, I use 3700. Okay? Again, when you look at it, the difference between these two divided by 360 is going to be 10 loops. And then say, okay, watch it. We say preview. And okay. Wow. It was fairly straightforward. But if you looked at this thing and say, how was this thing generated? That's kind of puzzling. Okay. So what I'm going to do now is while I'm here, I'm going to do an example which uses this information, a different subsurface, but I will use this information. What I want to do is this. I want to get the boundary of this curve, the boundary of this surface that I generated, and use it for some other purpose. Okay? All right, let's go ahead and do that. How do we get the boundary of a surface? This was done in earlier, well, actually, these are going to be discussed later on in future videos. However, just to show you how to get the boundary right now, which is all, it's a curve. All I want is a curve, okay? We can do that. So we go to, I think it's under transform. Let's see if we can find a boundary right there. See that? We're going to be discussing uh, the tab, all these other tabs in future videos. At this point, I have only done the wireframe tab, and I'm doing the surface tab right now in this playlist. Later on, we're going to be doing these other ones. But right now, transform boundary, I go and select the edge of this. So it doesn't matter which edge, you just say one edge, one edge. Notice what happens, it extracts the entire boundary of the surface. But I don't want the whole thing. I just want the bottom portion. And what that means, instead of point continuity, see that? Edge type, point continuity. In other words, extract anything that's connected to anything else as a boundary. I don't want that. I want, let's say, tangent continuity. And just watch what happens when I do this. When I do this, just shows the bottom portion. It doesn't take the stuff on the top. Look, when I do the point continuity, it also gives the other one, the top piece, the top boundary of each of these strips. But I want tangent, and then I say okay. Good. So what happened is I had this swept surface. I'm going to hide it. And these two sketches I don't need. They were used to create that swept surface. But I extracted essentially using this boundary, transform boundary, the edge, one of the edges of that weird, wacky surface. Okay, now I'm going to go to, again, surface. I'm going to go to sweep, once again, circle, but I want the center and radius. Center and radius. It means make basically a tube around some curve with a given radius. You can also change the radius if you want, but I'm not going to do that. So, okay, so what is the center? The center is that center curve is that thing that I just got, the boundary thingy right there. And the radius of the tube around this, let me make it for now 5, see how it looks like. We may want to make it bigger, smaller, depending on what you want. And preview. There we are. See that? So a tube has been generated. If you zoom in, you can see that a tube has been generated along that surface. Okay? Let's go and change the radius of it to maybe 10. Oops, not 100. 10, preview. There. it's fatter. Now, obviously, at some point, if you put a bad number, things are going to fall apart. I mean, let's put 100 here, see what happens. It may be weird or it may fall apart completely. Yeah, I mean, against that, I can't do that because these are interfering with each other. Okay, so I've done two of those four wacky surfaces that I mentioned, replicated the work of that YouTuber that I gave the reference of, and now I'm going to do the other two. Okay, this is now going to be example 3 from the indicated source. So let me hide the stuff that I don't want. Let me hide this boundary, hide that, and I'm good. These are already. Okay. So now I'm going to use a helix. Okay. I'm going to make a helix, and how to do that is to go to wireframe, and there is the helix option here, right there. On the wireframe tab, you have the helix. And the method that I'm going to use is let me see now, I will use the pitch and the number of revolutions. Pitch and the number of revolution, which is that one, the first one. Okay, for the pitch, the fellow puts uh, 50 millimeters. I mean, these numbers are not critical, but I'll try to stick to what he's using. And for the number of revolution, let me change it to 15. 15. All right. Now, notice that you have to create the start point, specify the start point. The default probably is 0, 0, 0. But what I want to do, since I did not have a point, I'm going to make one. Put the cursor there, right click, insert wireframe, create a point. And let me go ahead and move it in the X direction so that I can see where it is. I may have to adjust that a little bit because I don't exactly know what that fellow took. I think it was probably less than that. Once I create my helix, I'll have a better idea. Okay, good, good. And in the direction, direct axis direction being Z axis, yeah. So we can see something like that. Okay, I think that the point is further. Say okay. This point that I created, I'm going to make it further to the left. So based on that fellow's helix size and the location of and the height and the pitch and things like that, it's probably somewhere. Yeah, that's good. That's good. Actually, it's even further than that. So let me go make it 250 or 300. How about that? 300. Good. There. That's fine. That's fine. Very good. Now, notice that when I created my helix here, their helix, I had the option of specifying the taper angle. See that? Says starting angle 0, but you also have a taper angle. So let's make this thing 5 degrees so it looks like 5 degrees or 5 degrees. It looks like that. Okay. Very good. Now, suppose I want to take um, a circle and sweep it along that to get a tweet, a tube. So I go to the surface and sweep. It's a circle that I want to get as cross section. So it's a circle profile, and I want the center and radius. Good, good. Center and radius. So the center is going to be this, and the radius right now is 10. Let's see how it looks like. Yeah. Okay, that's fine. Let me make it a little bit bigger. Let me go here. Let me make this thing 20. See how it looks like now? Okay, good, good. This is fine. But suppose I want this the radius of this thing to actually decrease from 20 to some other value, say 5. Okay. So what I do, I go to sweep Under the law here, instead of constant radius, I'm going to make it linear. Obviously start at 20, and I'm going to make it drop to maybe, I don't know, 5. Say okay, and okay. So here what happened. You can see that based on the linear law over here, the radius is whatever I had. I think it was 10, and then gradually as it goes along the helix up here, it reduces to, to 20. Okay. Now there are other crazy things that you can do. If you go here to sweep, instead of the law being, for example, linear, you can make it S-type. So let's see how it does. S-type. Uh, so it starts at 20, then it decreases. Okay. Let's see now. So it's not linear anymore, but according to that curve. And if you wonder what that curve is, you have to look at the documentation. Not likelihood it's a cubic, some kind of a cubic probably, etc. But this is not linear anymore. Okay, so that takes care of the uh, wacky surface 3. Okay, my fourth wacky surface, or this fellow's fourth wacky surface, is something that I'm going to be doing next. So let me hide the stuff that I don't want. I'm going to hide the helix also. All right. So on the horizontal plane, I will draw a centered rectangle. That. Okay. And let me put some dimensions here to be consistent with the reference. So this one is, I believe, he is using 200 millimeter. And this dimension is going to be, say 100 millimeters. There we go. Now I want to put some corners around this thing, and the easy way of doing this thing, you select all of these, and then you go to corner, and then you can put any dimension that you want. So this dimension, I'm going to change this thing to, that fellow is using, I believe 20. So let's make it 20. Good. Exit. Now what I want to do is put a surface on this. Now that was done earlier in the videos of surface tab. It's FILL, fill. Outer boundary, there's only one boundary over there. And then we say OK. So it puts a surface there. What I also want to do is I want to use the parallel curve in order to basically draw these boundaries inward. There are other ways of doing it. You can draw a curve, on that face the way you want it, etc. But what I'm going to do is something that we have already done in the wireframe. And let's see if we can find a parallel thingy. Uh, it's got to be one of these. I can't remember. Parallel curve, right there. Click on the parallel curve. This dialog box opens up, and we discussed this thing in videos on wireframe. You select the edge of this, the edge of that. Okay. For the support, you select the surface. Okay, and we put down a 23 millimeter inward displacement. Okay, and there is an advanced option here. We change this thing from sharp to round corner, and then we say okay. So a curve has been created here, and now I want to put actually corners of a given magnitude at these four points. And where do we find the corner? If you go to the wireframe and look under this pull-up menu where you see a circle, any one of these things, there is this corner thing. You select it, and for the corner type, we use corner on a support, and check this corner on vertex too. Okay, and the element is that parallel curve that I created, and the support is that surface. Okay, and we're going to put, let me put 20 millimeters here, and see what happens. So, okay, there we are. So it created that curve here. Now, the whole purpose of this video, or this part of the video, is to go to surface, sweep. So now that we have done this, click on the sweep. It's a circle, profile is a circle, and we want the very last one, which is limit, curve, and tangency. So limit curve is that parallel curve that we created with the corner, remember that? And the support is that surface. If I put 20 millimeter here, it may come back and say it's too big. So what I want to do is a radius of a tube of radius 20 millimeter about that thing. Well, right now it's not going to be a tube because the angles are 0 and 100 by default. So I'll put 360 here, and then it becomes a tube. Now, when I say preview, it apparently, if you close this thing, you can see that maybe that number is too big. It's 20 millimeters too big. So let me go and change that thing to maybe a 5. And there we are. Okay. And then, of course, you can do all kinds of things. If you don't want to go between, for example, 0 and 360, you can go between, say, 90 and minus 90. Minus 90, see how it looks like? Okay. So basically, it gives you half of that. And there are all kinds of operations that can be done on this. So that wraps up the videos on the 4 wacky surfaces using the sweep icon and the circle profile tag. Take care.